Have you ever wondered if a machine could think? Or if technology could ever surpass the human brain? Welcome to the fascinating world of artificial intelligence, AI, and the historical Turing test that explores these very questions. In this two-part series, we will delve into the fundamental principles of the Turing test, the development of AI, and discuss whether AI can truly pass this test. Understanding the Turing test. The Turing test, proposed by British mathematician and computer scientist Alan Turing in 1950, serves as a benchmark for determining a machine's ability to exhibit intelligent behavior, equivalent to, or indistinguishable from, that of a human. Turing's initial concept involved a simple party game, known as the imitation game, where an interrogator converses with two players in separate rooms. One player is a machine, and the other is a human. The interrogator's goal is to determine which is which. If the machine successfully convinces the interrogator that it is the human, the machine is deemed to have passed the Turing test. This pivotally important test, while simple in design, challenges the very core of what it means to think and be intelligent. According to Statista, as of 2020, 37% of organizations have implemented AI in some form. Underscoring the growing relevance of this topic, the evolution of AI and its relation to the Turing test. AI has come a long way since Turing's time, and each advancement raises new questions about the Turing test. In 1997, IBM's Deep Blue became the first AI system to beat a reigning world chess champion, Garry Kasparov. In 2011, IBM's Watson won Jeopardy against two former champions. More recently, Google's AI program AlphaGo defeated a world champion Go player. However, do these victories mean that AI has passed the Turing test? Not quite. While they showcase the capability of AI to learn and perform specific tasks, the Turing test examines AI's ability to simulate human conversation and thought processes. Notable attempts have been made, though. In 2014, a chatbot named Eugene Goostman reportedly passed the Turing test by convincing 33% of human judges that it was a 13-year-old Ukrainian boy. Critics argue, however, that the chatbot's performance fell short of true intelligence, demonstrating programmed responses rather than genuine understanding. As we conclude part 1 of our exploration into AI and the Turing test, we are left with a tantalizing question. Can AI truly pass the Turing test? And if it does, what does this mean for our understanding of intelligence? In part 2, we will investigate this debate, discuss the limitations of AI and the Turing test, and consider how we might need to redefine the Turing test for the current state of AI. Until then, we encourage you to ponder. Does AI's ability to mimic human behavior equate to true intelligence? Can AI truly pass the Turing test? Picking up from where we left off, the core of the Turing test isn't whether AI can play chess or answer questions on Jeopardy. It's about convincing a human that they are speaking with another human, not a machine. So, has AI actually managed to clear this philosophical and technological hurdle? The debate rages on, and it's far from settled. While chatbots like Eugene Goostman have made headlines for passing the Turing test under certain conditions, many AI researchers and philosophers remain skeptical. Why? Let's break it down. First, passing the Turing test doesn't necessarily mean an AI system is truly intelligent or conscious. Most chatbots rely on pre-programmed scripts, clever wordplay, or dodging tactics to fool judges. For instance, Eugene Goostman's persona as a non-native English-speaking teenager allowed the bot to evade tricky questions by feigning confusion or lack of knowledge. It's an impressive feat in deception. But is that really the same as thinking like a human? Secondly, the Turing test is highly context-dependent. The questions judges ask, the length of the conversations, and even the judge's expectations can all sway the outcome. A short, surface-level chat might easily trip up a judge, while a long, in-depth discussion would likely reveal the AI's limitations. In fact, many AI programs that pass the Turing test do so in limited, controlled environments rather than in open, unrestricted conversations. Limitations of AI and the Turing test. Let's face it, current AI systems have impressive capabilities, but they also have clear weaknesses. Most conversational AI today, like the ones powering chatbots or virtual assistants, rely on patterns, keywords, and vast databases of information. They can string together plausible responses, but they still lack common sense reasoning, emotional understanding, and true self-awareness. For example, if you ask a chatbot, why did the chicken cross the road? It may respond with a pre-programmed joke, but if you dig deeper asking about the chicken's motivations, feelings, or historical context, the AI quickly runs dry. This highlights a key limitation. AI lacks an inner world or subjective experience. Moreover, the Turing test itself is not infallible. It measures only a surface-level imitation of human conversation, not the depth of understanding or creativity behind it. As MIT professor Noam Chomsky once argued, merely fooling someone doesn't equate to genuine comprehension. In a sense, the Turing test is more about perception than reality. It tells us when a machine appears human, not when it truly thinks like one. Statistics. How close is I to passing the Turing test? Let's look at the numbers to ground our discussion. Historical pass rates. Since the first Loebner Prize, a formal Turing test competition, in 1991, AI chatbots have typically convinced only 20–30% of judges that they are human in short sessions. Eugene Gustman's 33% success rate in 2014 was a milestone, but it fell short of a majority. IA's progress over time. According to a 2023 report by OpenAI, advanced models like GPT-4 can now fool over 40% of layperson judges in controlled Turing test style settings. However, expert judges remain much harder to convince, with pass rates dropping below 20%. Scope of AI deployment. As of 2022, an estimated 77% of devices globally use some form of AI. Statista. Yet, the vast majority of these are narrow ISA designed for specific tasks, not open-ended conversation. Number of Turing test attempts. Over the last 3 decades, hundreds of bots have taken part in Turing test competitions around the world, but none have consistently passed when judged by strict criteria or for extended periods. What does all this mean? Simply put, AI is getting better at playing human, but consistent, convincing human-like conversation remains just out of reach, especially when the judges know what to look for. Rethinking the Turing test for the future. Given IA's rapid evolution, many in the tech community believe the original Turing test may no longer be the best benchmark. After all, today's ICE can process more data and generate more natural language than ever before, but still struggle with context, empathy, and nuanced reasoning. This has sparked calls to redefine what it means for AI to pass as human. Some propose more comprehensive tests that include emotional intelligence, creativity, and ethical judgment. Others suggest domain-specific Turing tests, tailored for tasks like medical advice or creative writing. The ongoing conversation reflects a broader truth. As AI grows more capable, our expectations and definitions of machine intelligence must also evolve. The Turing test was revolutionary in 1950, but the future may demand new ways to measure and understand artificial minds. As we've seen, the Turing test is still a compelling benchmark, but it's just one chapter in the unfolding story of AI. In part 3 of our series, we'll dive into some fascinating fun facts about the Turing test, spotlight leading experts like Stuart J. Russell, and answer your burning questions about AI and its future. Stay tuned. There's plenty more to explore. Transition from part 2, having delved into the complexities and debates surrounding the Turing test and AI's ability to pass it. In part 3 we turn our attention to some intriguing aspects of this topic that you might not be aware of. So, fasten your seatbelts for some fascinating fun facts about the Turing test and AI. We also shine our author spotlight on an eminent expert in the field, Stuart J. Russell. Fun facts section. The original imitation game. Alan Turing originally conceived the Turing test as an imitation game. It was only later that it became known as the Turing test. Loebner Prize. Initiated in 1991. The Loebner Prize is an annual competition that awards the most human-like chatbots implementing the Turing test in practice. Eliza, the first chatbot. In 1966, the first chatbot, Eliza, was created at MIT. Even though it was far from passing a Turing test, Eliza demonstrated the potential of AI to interact with humans. Eugene Gustman's success. Eugene Gustman is the only chatbot to date that has had significant success in passing a Turing test. However, it did so by representing itself as a 13-year-old Ukrainian boy with a limited grasp of English. Limited scope of AI. Despite the hype, most AI systems today are narrow AI, designed to accomplish specific tasks. General AI, which could theoretically pass a Turing test, remains a distant goal. Turing test in pop culture. The Turing test has been featured in many movies, including Ex Machina and Blade Runner. Debating the Turing test. The validity and usefulness of the Turing test have been widely debated. Critics argue that it focuses on appearance rather than understanding. Alternative tests. Many alternative tests to the Turing test have been suggested. These include the Winograd Schema Challenge and the Chinese Room Argument. The Chinese Room Argument. This thought experiment argues that even if a machine behaves as if it understands Chinese, it does not necessarily understand Chinese, challenging the validity of the Turing test. Turing's prediction. Alan Turing predicted in 1950 that by the year 2000, machines would be able to fool an average interrogator at least 30% of the time during a 5-minute conversation. Author spotlight. Stuart J. Russell. Stuart J. Russell, a British computer scientist, is a noteworthy authority in the field of AI, known for his extensive research on machine learning and artificial intelligence. He co-authored the widely used textbook, Artificial Intelligence, a Modern Approach. He is a strong advocate for the responsible use of AI and has contributed significantly to dialogues about the Turing test. His insights into the future of AI, the ethical implications, and the dynamics of the Turing test have been invaluable. Transition to FAQ. Now that we've had some fun with facts and shined some light on an AI expert, we will be moving to the next part of our series. In part 4, we will be addressing some frequently asked questions about the Turing test and artificial intelligence. So, stay tuned to have your queries answered and delve deeper into this fascinating subject. FAQ section. What is the Turing test? The Turing test is a method proposed by British mathematician and computer scientist Alan Turing in 1950 to determine whether a machine can exhibit intelligent behavior that is indistinguishable from that of a human. How does the Turing test work? The original concept of the Turing test involved an imitation game, where an interrogator communicates with two hidden entities, one human and one machine, and tries to differentiate between them. If the machine can convince the interrogator that it is the human, it is considered to have passed the Turing test. Has any AI passed the Turing test? The chatbot Eugene Gustman reportedly passed the Turing test by convincing 33% of human judges that it was a 13-year-old Ukrainian boy in a controlled setting. However, many researchers argue that this doesn't represent true artificial intelligence. What are the criticisms of the Turing test? Critics argue that the Turing test focuses on the appearance of intelligence rather than genuine understanding. They note that a machine can be programmed to mimic human-like responses without truly comprehending the information. What is the significance of the Turing test in AI? The Turing test serves as a seminal benchmark for AI's ability to mimic human intelligence. Despite its limitations, it has guided much of AI development and philosophy. What are the alternatives to the Turing test? Some proposed alternatives include the Winograd Schema Challenge, which tests AI's ability to understand written text, and the Chinese room argument, a thought experiment that questions whether a machine can truly understand or merely simulates understanding. How does the Turing test relate to AI in popular culture? The Turing test has often been portrayed in popular culture, especially in science fiction movies like Ex Machina and Blade Runner, where AI entities are examined for their ability to mimic human behavior. What is the current state of AI in relation to the Turing test? Despite advancements in AI, no machine has consistently passed the Turing test in open, unrestricted conversations. Most AI today is designed for specific tasks, and a general AI that could pass the Turing test is still a future goal. Who is Stuart J. Russell and what is his take on the Turing test? Stuart J. Russell is a renowned computer scientist known for his research on AI. He co-authored the textbook Artificial Intelligence, a Modern Approach, and advocates for the responsible use of AI. While he acknowledges the Turing test's historical importance, he also highlights the need for AI to demonstrate genuine understanding, not just mimicry. Is there any relevant Bible verse related to the Turing test or AI? The Bible does not mention AI or the Turing test directly. However, Proverbs chapter 16 verse 9, NKJV, a man's heart plans his way, but the Lord directs his steps, is often referenced in discussions about the unpredictability and inherent limitations of human-made creations, including AI. Conclusion. As we conclude our exploration of the Turing test and AI, we realize that this concept continues to shape AI development and philosophical debates about intelligence. It's clear that AI has come a long way, yet the journey to general AI, which could pass the Turing test convincingly, is still ongoing. The future of AI and its potential to pass the Turing test depends on several factors, including advancements in machine learning, ethical considerations, and our evolving understanding of intelligence. As we navigate these waters, let's remember Proverbs chapter 16 verse 9. We may make plans and develop technologies, but there are always factors beyond our control. For continued exploration of AI and its intersection with philosophy, science, and ethics, we recommend you visit Artificial Intelligence, a Modern Approach, co-authored by Stuart J. Russell. Confused about where to start with AI? Best-icourse.com maps your learning journey.